6.1.2 Restricted Domains. Essential question. Why are restricted domains necessary for some inverses? Skill. I can find restricted domains of functions to make them become invertible functions. Find the two possible inverse functions for the function f of x equals 5x squared minus 4 and f of x's respective restrictive domains. First, let's just find the inverse. So the first thing we want to do, instead of f of x, let's just write y. Y equals 5x squared minus 4. Switch the x and y positions. And then now we're going to solve for the new y. Add 4 to each side. Divide by 5. And then get the square root of each side. So then we have y equals plus or minus the square root of x plus 4 over 5. So then we either have f inverse of x equals square root of x plus 4 over 5, or we have f inverse of x equals negative square root of x plus 4 over 5. So let's write those as a blank. Everything's the same except for one's a positive, one's a negative. If you were to graph these, the parent function, the original function here, is 5x squared minus 4. It looks something like this. And then the inverse function would look something like this. Now, if you graphed both of those together, it would no longer be a function, since it would fail that vertical line test right there. So that's why you have to restrict the domain for it to actually be an inverse function. You'll do that by looking at the vertex of the original function. It's decreasing when x is less than 0, and it's increasing when x is greater than 0. So for our positive inverse function, the restricted domain would be talking about this side, 0 to infinity. For a negative inverse, it's going to be the other side, negative infinity to 0. It's the h value of f of x. There was no horizontal translation, so that's why it's 0. If you graph both the inverse and the function on the same graph, you should have a line of symmetry at the line y equals x. If you graph this on the calculator, you can clearly see that line of symmetry right here. Let's see our restricted domains. Let's do just the positive inverse. X is greater than 0. And see, it still is symmetric here. And then if it was less than 0, that would be symmetric with the negative piece here. Alright, try the other examples on your own.